All right, 9. So let's take a look at question number 4. Question number 4 says if you double the radius of the base of a cone of height h, what effect will that have on the volume? So first, why don't we just write down the formula? So we know that the formula of a cone is equal to the area of the base, which is pi r squared, times h all over 3. So in this case, we want to double the radius. So that means instead of r, we're going to have 2r, double the radius. So I'm going to do pi times 2r all squared times h all over 3. So then I get pi. Now, if you remember when our exponent rules, it says if you have ab to the m, so let me just write that over here, ab to the m, if you remember, that was a to the m times b to the m. So that number goes with both pieces inside the bracket. So we have 2 squared, right? 2 squared, which is 4. And then we have r squared h over 3. So now I have 4 pi, right? Because we always put the number before the pi, r squared h over 3. Well, if I compare my original volume, right, this is the volume formula, to my new volume, so let's call this volume 1, and we'll call this one volume 2. So if I take a look at volume 2 is 4 times bigger than volume 1. So therefore, it will quadruple the volume, or the volume will be 4 times bigger. So now let's see what happens when we change the height. So again, I've got volume 1 is equal to pi r squared h over 3. And now I want to triple the height. Well, if I triple something, it's 3 times, so I would use 3h. So volume 2 is going to equal pi r squared times 3h all over 3. Well, that's, if I always pull the number to the front, so I pull out the 3, pi r squared h all over 3. Well, if I compare volume 1 and volume 2, volume 1 is pi r squared h, volume 2 is pi r squared h over 3, volume 2 is pi r squared h over 3, but this is all being multiplied by 3, so obviously it has tripled the volume. So tripling the height will triple the volume. Hope that helps.